the first topic or first item at the top of the page there, bond energy. We will talk more formally about bond energy when we talk about thermodynamics. Today, all I want you to know is that there's energy needed to make or break a bond. Okay.
Of course, sir.
And anytime that there's a chemical reaction, there is an exchange of energy. We're not going to focus on that today. However, what we are going to focus on today are formal charges. Up until this point, I've, and a couple other chemistry teachers have led you to believe that you've been drawing your Lewis structures correctly. We've been lying to you. Okay. Not everything, just some things. The reason why we did that is because we did not want to introduce formal charges to you as a general chem student because it might be a little more complicated for you. Now that you know how to draw Lewis structures, we're just going to make a quick adjustment. Okay? And I'll tell you when we make that adjustment. But looking at sulfate, SO4, with a -2 charge, we still want to do the same thing. We want to find out how many valence electrons we have. So how many valence electrons does sulfur bring? 6. And how many does oxygen bring? 6. And we have 4 of those. The -2 means what? We're going to add 2 more electrons, so that gives us a total of 32. That's still the same. They're not going to change that.
38.
Okay.
38, actually. I got it wrong. No, 32. 32. Mark. Okay. 30.
If you need to use your calculator, that's fine. All right. Also, arranging our atoms, in other words, putting sulfur in the middle.
Oh, yeah.
Still going to do that, putting the oxygens around. And then I told you all, make sure that you satisfy the external with their 8. Still going to do that. And so we make sure that everybody has 8 electrons, and they have that. What's the -2 mean again? We had to add 2 electrons to make sure everybody was happy. So that means we need to put brackets around all of that. And if you were in general chem or you drew this yesterday, we'd be done and you'd be happy. And I'd be thinking to myself, they're going to learn how to do it right tomorrow. Okay? And that's fine. I don't have a problem with that. Today we're going to learn about formal charges. And formal charges will give us the correct structure. That's not the real way it looks. Okay? On the sheet that I passed out to you, there's a lot of information on there. You want to read it, that's fine. But I'm going to show an example on how to fix this. First thing that we're going to do is look at the oxygen. And when I talk about an oxygen, I'm actually talking about each one of these as a single bonded oxygen. What we want to do first is we want to find out how many assigned electrons we have. How many assigned electrons we have. And the way to do that, I'll push this into the screen so we can see it, is when we talk about assigned electrons, we want to look at the structure and ask ourselves, how many lone electrons? Lone electrons. Now what is a lone electron? Or lonely electron? It means it's not being shared. Okay? If you're alone, you're not sharing yourself with anybody. Some of us will have to do that in life. It's okay. Plus, we're going to find out how many are shared. But we'll only count half of that. So, half shared. And these are electrons, not pairs. Okay? So don't think of pairs when you do this. Talk about electrons. Okay? So once we have that value, then we want to do our formal charge. And the formal charge is how many valence electrons that element brings minus the assigned. Okay? Now you can always play this video back to see that if you need to. But luckily you guys are in class so you get to see it right now. It's out of the picture now. Alright, so going over the assigned, how many lone electrons is on this single bonded oxygen? How many lone electrons? or not shared electrons are on that oxygen?
6.
Yeah, so we have 2 there, 2 there, and 2 there. So we have 6 electrons that are not being shared, plus 1/2 of how many that are being shared? 2. Okay. So that'll give us a total of 7 electrons that are assigned to this single bonded oxygen. Now to do the formal charge here, how many valence electrons did oxygen bring to the party? 6. And we'll subtract that from our assigned value, which gives us a value of -1. Now, the bad news is, these want to have a formal charge of 0. Oxygen does not at the moment. Okay. All right. To help, let's take a pair. And again, we're experimenting, so this might work, this might not work. Okay. So now that we have a double bond here, we took a pair and we moved it so that we now have more shared pairs and less lone pairs. And this is our single bonded oxygen. Let's do the same thing with our double bonded oxygen. How many assigned electrons, and I wish I could abbreviate assigned, but it wouldn't look very good. So how many lone electrons do we have on the oxygen? 4, very good. Plus 1/2 shared, how many do we have shared?
2, 4, and
4, very good. 1/2 of 4, which gives us a value of 6 assigned electrons. So the formal charge calculation for this is there are 6 valence electrons minus the assigned, look at that. The 4, right here. Are we talking lone or shared? The lone, I have 2 there and 2 there. And it's electrons, not pairs. Okay. And then I have 4 shared, and you may not be able to see it all the way back there. I apologize for that. Yes, Richie?
So that doesn't mean that all of them have to be double bonded, does it?
The oxygens?
Yeah. They don't have
Oxygen, when it has a formal charge of 0, is double bonded. Okay. Yeah, Taylor.
Okay, but I'm confused now because sulfur has 10.
Oh, let's not look at sulfur just yet.
Okay.
We'll do one thing at a time here.
Alright.
Okay? Actually, this is a pretty good time to talk about it. I'll get close enough here so you guys can see, those of you at home. If we look at oxygen, how many valence electrons does it have? How many more does it need to have an octet? 2 more. Things that are nonmetals, oxygen, sulfur, and selenium, when they are external atoms, want to have a double bond to have a formal charge of 0. Again, elements that are in group 6A that are nonmetals, oxygen, sulfur, and selenium, when they are an external atom, they want to have a double bond to have a formal charge of 0. Okay? Looking at group 7A, how many valence electrons do they have? 7. How many more electrons do they need to have an octet? 1. You'll also find out, as external atoms, those elements in group 7A want to be single bonded as external atoms to have a formal charge of 0. I'm saving you guys a ton of time right now. Isn't this cool? If we come over here to nitrogen and phosphorus, those are really the only 2 nonmetals that we care about. How many valence electrons do they have?
5.
So how many more do they need? 3. So they want to have a triple bond as an external atom. And again, all these scenarios or cases are external atoms. Atoms that are not centrally located. Okay? And I got to ask, if we look at carbon, how many valence electrons does it have? So what kind of bond does carbon want to have as an external atom?
Two double bonds. That's gonna be some.
Atta girl. Carbon's never an external atom. And there's no such thing as a quadruple bond. See, I can do that because it's not going to be on camera. Okay, so really, group 5A, triple bond. Group 6A, double bond. Group 7A, single bond. Okay? No quadruple bonds. And carbon is never an external atom.
Ever?
Ever. Ever. All right, so who asked about this? Was that you, Taylor? All right. So let's do a formal charge calculation and see if sulfur is happy, because we always want the central atom to be 0. We've got to have the central atom as 0. So let's do it. All right, so looking at the assign for sulfur here, and I'm not going to say if it's double, triple, whatever. It's whatever it is right now. How many lone electrons? 0. Very good. Plus 1/2 shared. How many are shared right now?
5, 8,
10, right?
10,
5, 8. So the assigned value is 5. All right, the formal charge. How many valence electrons does sulfur bring? 6. So minus 5. Uh-oh. Gives me a plus 1. Is sulfur happy? No. So to get sulfur to have a formal charge of 0, what do we need to do? Not to this oxygen.
Make a double bond with another oxygen.
Which one do you want it to be?
I don't care.
The other one, just to keep it symmetrical? All right, that's fine.
You don't want asymmetry.
It doesn't matter. Yeah, it really doesn't matter. But for aesthetics, boy, doesn't that look pretty that it's in the line? Okay. All right, so now, here's what we know. We know that this oxygen has what formal charge? -1, because it's single bond. This oxygen also has a -1 formal charge. These two oxygens have a formal charge of 0. Do we need to do the formal charge calculation for this sulfur? Yeah, let's do it real quick. Change that 10 to a what? 12. So that makes that a 6. Change that one to a 6. Aww. Happy. Now, is this a good structure?
Yes.
Taylor says no.
I'm all around.
You're all around. What's that? Now, oh, yes, Danielle.
Why can't you just say, instead of half share, why can't you just say the number,
I don't know why I can't say that. I wasn't taught that. All right, now here's what's really cool, and I haven't said this. What's the charge as a whole on this whole compound? -2. The formal charges have to equal the total charge.
So then the negative charges from both the single bond oxygens add up.
There we go. So we know that that's 0, that's 0, that's 0. Okay, 0 plus 0 plus 0 is 0. Then we have 2 -1s. This is our structure.
What are the cases in which we add electrons that weren't originally there? Is that with the
Typically polyatomics. Is that what you mean?
She would have something with X's, and we would. No,
Don't do that.
Okay. And
We don't care.
But it gets to the same point as that does.
Yeah, yeah.
Okay.
In other words, 2 of these electrons
Aren't actually.
are from some metal. That's what that -2 means. That some metal gave it 2 electrons. We don't care we're sharing. And metal was gracious enough to give us 2 electrons. Which 2? We don't care. Just as long as we've got 32 electrons to make everybody happy. As long as they get their electrons, they're happy. All right. Was I going to say something else? I think I'm good. All right. Take a look at the others. Are there any questions on this? Now, let me say this. Formal charge calculations are a good idea for the central atom. Okay? Formal charge calculations are a great idea for the central atom. You should never, ever have to do a formal charge calculation on an external atom now that you know the secret. Okay? Group 5A, triple. Group 6A, double. Group 7A, single. There are no other options. Okay? We can't stick metals on here. They don't want to do that. They don't want to share. So if you're not 100% sure, then do a formal charge calculation for your central atom. Okay? Also, all right.
Sorry, Mr. Beck.
It's all right. Don't scare an old man like that. See the lawsuit now. All right.
Man, Cole's missing out. What's he doing?
When we talk about formal charges, this is a great rule to use for most compounds. For most. In other words, formal charges don't always work for everything. What are those exceptions? That's a good question. These guys right here, sometimes, not necessarily carbon. Carbon's usually pretty good. Actually, I'll just go with NOF. Carbon's typically good about it. But these guys, nitrogen, oxygen, fluorine, sometimes formal charges won't work if they're a central atom. As external atoms, no problem. But central atoms, they sometimes give us a hard time. So if the formal charge does not work, make sure everybody has an octet. Okay? Now, why would nitrogen, oxygen, or fluorine not work well as a central atom? Look at this condition right here. How many electrons does sulfur have? Or sharing, I should say.
6.
That's pairs. How many? There's 12 there, right? How in the world are we able to put 12 electrons around that sulfur? Or for sulfur to even say that it has access to 12 electrons? Bless you.
Because it's bonded to something else.
Okay.
I mean,
Probably-
bonded to something besides what we have right here.
Let me say that we tried to do that. That's a big no-no.
Yeah, that's not gonna work.
Why? Why is that not going to work?
Because, well, the numbers don't work out.
Okay. They don't work out, but why? I guess the reason my question is, why would this number of electrons not be good for nitrogen or oxygen or fluorine as a central atom?
Does it have something to do with
No.
the atomic radius?
Let's back up the wagon just a little bit. What does sulfur have access to that nitrogen doesn't?
Another electron level. Another energy level.
Which has what kind of orbitals?
D.
D orbitals. Very good. So when you look at nitrogen, oxygen, fluorine, the maximum number of electrons they can have as a central atom is 8, an octet. Sulfur, okay, if I put this back, sulfur can drop electrons in the s orbitals, the p orbitals, and d orbitals. They only have access to s and p since they're in the second energy level. Okay? So most of the time, formal charges will work out great. And they'll work out sometimes with these guys too. But if you do your formal charge calculation, you go, oh, to get this to work, I'm going to have to violate the octet rule for nitrogen, oxygen, and fluorine. And we can. We can with sulfur because we have d orbitals. These guys, no. So if you see nitrogen or oxygen or fluorine as a central atom, you should kind of go, I got to look at this really carefully. You got sulfur, phosphorus, chlorine, all those other non-metals that are below the second row, you're golden. Okay? And just do a formal charge calculation as well. All right, let's look at the other example. Is that SO2Cl2?
Yeah.
Okay. Good news is you'll never have to name that. All right, so let's find out how many valence electrons. Sulfur brings 6. Oxygen brings 6, and there's 2 of those. Chlorine brings 7, and we have 2 of those. So, 14, 32? All right. Who's my central atom? Sulfur. Okay. So we'll put the sulfur in the middle. Actually, I'll put it over here. Yeah, I'll put it over here. And then where do you want to put the oxygens? What was that? You want them to be up? They don't have to be, but if you want them to be, is this okay over here like that? Okay. I mean, I'll do what you want. I mean, chlorines go there. All right, now, we still want to satisfy the external atoms first by giving them their 8. but let's be smart on how we do this. Before we even put any dots or lines on here, what's my total charge on this compound? 0. So everybody wants to have a formal charge of 0. That's what we're going for. So the external atoms will have a formal charge of 0, and the central atom better have a formal charge of 0. So what should I do to the oxygens? Double bond them. Good. And that's working smart, because again, you shouldn't have to do a formal charge calculation. If you need to today, that's fine. But after today, you're going to draw your Lewis structures correctly, knowing formal charges. And the reason why I showed you that little trick, and most teachers don't do that to their students, okay? The AP exam is a sprint. You've got to go fast. You need to be efficient, and you got to get things done quickly. And wasting your time doing formal charge calculations is not being efficient. So what kind of chart, or what type of bond do we have on the chlorine? Single bond. Okay. So we know that that's a formal charge of 0 for the single bonded chlorines, and if you need to do that calculation, go for it. And the oxygens are also double bonded. Sulfur, I think in the last one we had how many shared pairs? 12. How many do we have here? 1/2 of 12 is 6. 6 valence minus 6 assigned, 0. It's a good structure. Okay. Yeah, Ashley.
How did you know that the oxygen was not double bonding?
Okay. Again, when you look at your periodic table, since it's 2 away from having the same electron configuration as noble gases, all those elements as an external atom will be double bonded.
So
And
it's a whole row of oxygen.
the column, yeah. So like, well, there's only really 3 nonmetals that we care about: oxygen, sulfur, and selenium.
Alright.
Those 3 as external will have double bonds. And then in group 7A, fluorine through iodine are going to be single bonded. That's why I have the chlorine as a single bond. And then looking at the nitrogen and phosphorus, they only have 5 valence electrons. They're going to have a triple bond as an external atom. And that's how you speed this up. Okay. What we did yesterday and in General Chem was fine. I mean, you got to work on your octet rule, but this is really how it's done. Okay. Want to do one more example? I don't have it on your sheet, but the examples that I showed you yesterday, like the phosphorus trichloride, let's do that one. See if we drew that one correctly yesterday.
Great.
Yeah.
Okay, I'm gonna make sure I have your cheat codes written down.
Sounds fine. Cheat codes are good to have, yeah.
And like column 5 is triple.
As an external atom, you know what that means. Outside atoms. They want to be bonded to the central atom as a triple bond.
Yeah.
Okay,
6 is double and 7 is single bond.
perfect. Yep, very good. All right, PCl3. That was our first example yesterday that we worked out. So we had 5 valence electrons and then 7 times 3 for a total of 26. Phosphorus we had as a central atom. Chlorines we had around the horn. What kind of bond do I want to give to the chlorines? Single, and I think we did that yesterday. And then what did we do with the other 2? Place them on the phosphorus. Okay. So we know the chlorines are good. They're single bonded. Phosphorus, let's do a formal charge calculation for that. So the assigned, how many lone electrons on phosphorus?
1.
2, very good. Not pairs, electrons. So we have 2 there, plus how many are shared? 6. So that gives us how many total? 5, very good. You could always use a calculator. And then the formal charge, how many valence electrons does phosphorus bring? 5. Minus the 5. All right. We did it right yesterday. Okay. And that was by accident. But the key here is, don't forget when you're looking at your central atom, if these are not being shared, okay, we count all of it. Okay. The only ones that are being shared are the 1/2. All right. One of your homework problems does not follow the formal charges, but we want it to follow octet. Okay, I'm not going to tell you which one, but one of them will not obey formal charges, and that's okay. Again, formal charges is a good guide. It's not the absolute rule.